talking about the minimum and maximum of a quadratic function, and most of what we're doing will be problem solving with this concept, because this is something we talked a lot about in grade 10 when we learned quadratics, and this year it's also very important. It just becomes a bit more complicated. The problem solving aspect of it becomes a lot more involved. So you really need to pay attention to this video. You really need to make sure you understand these examples, rewatch them if you need to, and note any questions you might have as we go along. So first we have to remind ourselves, how do we find the vertex from any of the three forms of a quadratic? So we've done this before, but just so you have it on this note, from vertex form, it's given to you as hk. Okay? From factored form, you take the average of the zeros, and that's your x value. Okay? And then to find the y value, you just sub that x value into the function. For standard form, you find x is equal to negative b over 2a, that's the x value of the vertex, and then sub that x value into y, into the function to find the y value. Okay? It's really important that this stuff by this point is just second nature to you, and you're not getting it confused with finding the zeros. You have to make sure you know the difference between finding the vertex and finding the zeros for problem solving purposes. You remind yourself that if the function opens up, so if a is positive, then the oh, I have that messed up. See, that's a common mistake. Even I can make it. Okay, in fact, there you go. So if a opens down, then you have a maximum, and if a opens up, then you have a minimum. Okay, make sure you get that straight. Okay, so when you're doing these word problems, you have to consider the form of the equation and then how to find the vertex. Analyze what the vertex zeros and other features mean within the context of the problem, and then use the proper technique. So different applications are maximum height, minimum cost, maximum profit, maximum area. Anytime you're looking for maximum, minimum, best, worst, okay, any extreme like that, you should think vertex, 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 all right? Now, remind yourself of the revenue, profit, cost relationship, because a lot of the questions have to do with that. So revenue is how much money you take in. So it's going to be the number of items you sell or pick or whatever times the price per item. Okay, so that's how much you're selling it for. So if I am selling t-shirts, my revenue is I sold 20 t-shirts and I sold them for $10 a piece. Okay, the cost is the number of items times how much it cost you. So I bought those t-shirts for $5 a piece. Okay, so it would be 20 times 5. So price and cost are not the same thing. Price is what you're selling for. Cost is what it cost you to make it or buy it yourself or whatever. And then the profit is the difference between these two. So how much you end up actually taking home at the end of the day after you've paid your costs. So if you want to represent that in function form, it's just p at x equals r at x minus c at x. So be careful not to confuse the difference between revenue, cost, and profit, and that you know how to find all three of these. So our first example is one of these typical throwing a ball up in the air questions. So they want to know what's the maximum height, how long did it take to get there, how high is the roof, and when did the ball hit the ground. Okay, so these two, maximum height and how long it takes to get there, we can kind of do together. Those both have to do with the vertex. Okay, see that word maximum, you should think vertex. How high is the roof? Well, it's thrown from the roof, so this is really just asking for the y-intercept. And when does the ball hit the ground? So when is height 0? That's asking for the x-intercept, or the 0. Okay, so now that we've identified what features each of these refer to, we can go through and do the math. So we can kind of do A and B together. Okay, so this is in standard form. So to find the time, you make sure you use t here, not x. We just do negative b, so minus 20 over 2a, so 2 times negative 5. So negative 20 over negative 10 is positive 2. Okay, so H at 2 then, we sub that in, do the math, you get 70. So then you can say, therefore, and this is answering A and B, the max height is 70 meters. Make sure you put the units. And it takes 2, I think it's seconds, yeah, seconds to get there. Okay, so that's A and B. C, we just need to find H at 0, which is 50. So you can do a little sentence there. So therefore, the height of the roof is 50 meters. Make sure you put the units. And finally, D. Okay, so let's remember to find the x-intercept. Either you can factor or you can use quadratic formula. So in this case, it's actually not factorable, so I use quadratic formula. So H of t, I'm first going to factor out that -5, just so my quadratic formula doesn't have such big numbers. Okay, so -5, take that out, then I get t squared minus 4t minus 10. So make sure you do that properly. If you're concerned that you're not going to factor out the -5 properly, then you should just leave it in and just deal with the big numbers in your calculator, because you'll still get the same answer if you don't factor out the -5. I just think it's kind of annoying to have such big numbers personally. So then I say t equals -b, so 4 plus or minus the square root of b squared, so 16 minus 4 times a, 1 times c, -10 all over 2a, so over 2. If you put this in your calculator, you get t equals 5.74, or t equals minus 1.7. So this is inadmissible because time can't be negative yet. So then this is our answer. Okay, so therefore the ball hits the ground at approximately 5.74 seconds. Okay? Pretty much a basic question right out of grade 10. So that's the first type of question when it's really basic like that. I call it basic because you didn't have to come up with the formula. The formula was given to you and everything. What it was asking is pretty straightforward, just an application. Okay, here we get a little more complicated in 2 and 3 because the numbers look a little uglier, so some of us freak out. And 3, we actually have to come up with a formula. So the cost per hour of a bus is represented by this function, okay, where x is the speed of the bus and c is the cost in dollars. Determine the most cost-efficient speed and the cost at that speed. So you might want to think about why on earth I underlined the most. Okay, well that's because it indicates that we're trying to find the vertex here. It's that word most that is important. So we just need to find the x value of the vertex. And we notice that this is in standard form, so we just use minus b over 2a. So positive 0.48 divided by 2 times 0.0029. Okay? That comes out to 82.76. And remember, this is speed, so that would be kilometers per hour. Okay? Then you put that into the cost function, so cost at 82.76 gives you 122.14. So you put a nice little sentence saying that the most cost-efficient speed is 82.76 kilometers per hour, or you could say approximately 83 kilometers per hour, and the cost of that speed is $122.14. Okay? Now with 3, demand function, okay? So the demand function for a new magazine is blah, 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 blah. So demand function means basically how many are being sold, okay? So the demand function is how many magazines they're selling, or the demand for that magazine. So if you need to write that there on the side, that's an important thing to know. So P at X represents the selling, oh, sorry, I just said that wrong. Because here it says P at X represents the selling price in thousands of dollars of the magazine. Oh yeah, and X, the number sold. That's why I was getting confused. Okay, let's rewind there. So the demand function here represents price. P at X represents the selling price in thousands of dollars of the magazine, and X is the number of magazines sold in thousands. Okay? The cost function is the total cost. It's given to you right here. So we want to come up with the maximum profit. So to come up with maximum profit, okay, profit, remember, profit is revenue minus cost. We need to first come up with the revenue function, because we're not actually given the revenue function. We were given the price function and the number sold. So first we need to come up with the revenue function, which is the price times, so P at X, the price, times the number sold, which we know is just X. So it's minus 6X plus 40, that's the cost, the price function, times X. So minus 6X squared plus 40. Okay? And we're already given the cost function, so we don't need to find that. Okay, so our profit function then is our revenue, so minus 6X squared plus, oops, that's 40X, plus 40X. Subtract our cost function, so 4X plus 48. There we go. Okay, make sure you put this in brackets because you have to show that you're subtracting the entire cost function, the 4X and the 48. So now we collect like terms, minus 6X squared plus 36X minus 48. Okay? So you could factor out a negative 6 here if you wanted, but for vertex it doesn't really matter. So now we need the vertex of this profit function. So our X equals minus 36 over A minus 6. So that gives us 6. Okay? So that means this is the number of magazines in thousands they need to sell. Okay? So therefore, sell 6,000 magazines to earn the maximum profit. Okay? And so to find the maximum profit, you just put the 6 back into the function and you get your maximum profit. Okay? So I'll let you go ahead and do that. All right. Now we really go back into grade 10 with our whole ticket situation. I don't know if you remember this, but this was very common type of question about price changes last year. So price changes that go up and price changes that go down. So a ticket to a school dance is usually $8 and usually 300 students attend. But now they want to increase the price by $1 or more. They say for every $1 increase, 30 few students come to the dance. What ticket price will maximize revenue? So notice they only care about revenue here, not profit. So you don't have to worry about the cost of the dance, just how much money they're taking in. So remember that when you have these types of problems with a price increase or decrease, the best thing to do is you let X represent the number of price changes. Okay, the number of price changes, how many times you're changing the price by $1. So we should actually say the number of $1 price changes. Okay, so we want our revenue function is going to be equal to, sorry, it's an R. Our revenue function is going to be the price of a ticket times the number of tickets. So think about it. The price of a ticket right now is $8, and it's being increased by $1 times however many times we increase it by $1. So if X is 1, it's $9. Okay, if we increase it to $10, then X would be 2 because we did 2 $1 price increases. Okay, if we reduce the price to $5, then X would be -3, showing -3 increases. Okay, Then the number of tickets sold, we started at 300, but we're subtracting 30 every time we've changed the price once. Okay, so X again represents the number of price changes we're doing. Okay, so now we want to maximize revenue. So we go through and find the maximum, the vertex of this function. So you have a couple ways of doing this. Either you can find the zeros from this form, or you can expand this and then do minus b over 2a. I just found the zeros and then averaged them. So I said here we have x equals negative 8 as this 0. And here we have x equals 10 as this 0. So the average of minus 8 and 10 is 1. So therefore, it says what ticket price will maximize revenue. So therefore, there should be one $1 increase. So therefore, ticket price will be $9, right? Because we increased it once. If you get a negative number in a question like this, that's okay. That just means you're decreasing the price. Okay, it just asks for what ticket price. If it asks for what the revenue